Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at special angles. In particular, we're going to focus on one type of special angle, the 45, 45, 90 triangle. So let's go ahead and get started. So here I already kind of drew my unit circle, and so we're going to deal specifically, like I just mentioned, with the the 45, 45, 90 triangle. So I'm just going to draw this. This is not drawn to scale, obviously. But I just want to make sure I have lots and lots of space here to, I don't want it to be like that. Lots and lots of space to kind of explain things to you. So here's my triangle. So we got 45 degrees here. And so right here, because we're always going counterclockwise, this is going to be 45 degrees here. This is going to be 45 degrees here. All right. Now this is a unit circle, so that means the radius is going to be 1, like so. And then of course, what we want to figure out is this guy right here, the XY coordinates. This is what we want to know in this particular video. All right, now there are some things. First of all, I'm going to show you this for right now, but we're going to deal with it later. It's not critical right now, but we want to convert this 45 degrees into radians. And you can calculate this on your own time, but 45 degrees is going to be the same as pi over 4. So just keep that in mind, but we're not going to deal with that just yet. Now let's go back to our main point. Now here's the thing, because these are the same degrees, 45 and 45, that means that essentially, I could just put like my little dash here, that the length of these two sides are going to be the same as well. And so what that means is that x is going to equal y is going to equal x. And so this is going to be very, very valuable as we go forward because they're the same length. We know that because they have the same degrees. Now, if you recall, we've talked about this in a prior video, the way to find the area of a circle is x squared plus, for the unit circle, x squared plus y squared equals 1. That's kind of how you do that. Now, remember, x and y are the same. So I can replace the y with x, or I can replace the x with y. But to make life simple, I'm going to replace the y with the x. So to continue my thought here and try to follow this, we now have x squared plus x squared equals 1. Now I can combine like terms here, and I end up with 2x squared equals 1. I'm getting close. Now I can divide both sides by 2. I'm just trying to simplify this, and I get x squared equals 1 over 2. Now I square root everything, like so, and I get, watch this carefully, x equals 1, because the square root of 1 is 1, over the square root of 2. Now, way a long time ago, when we were dealing with other topics in intermediate algebra, you know that we often do not like to have a square root in the denominator. So what we do now is we rationalize the denominator, which means we multiply it by square root of 2, because that's in the denominator, and we end up with, and this is kind of our final answer for right now, square root of 2 over 2. That is kind of our final answer here. So what we can say now is this. Now remember, x equals y in this case. In other words, the coordinate of x is square root of 2 over 2. The coordinate of y is square root over 2. And that is how you get the answer. Now, we need to confirm this, because whatever answer we got, please follow closely here, whatever answer we got, if we do this, we should get 1. So let's go ahead and take a look at that. I already put this inside the calculator. All right, so we're going to start with this one. Okay, so I hope you can see that. You can see here it has the sine of square root of 2 over 2. Actually, I don't even really need that. Sine of square root of 2 over 2. Divided by 2, cosine square root of 2 over 2. If I put all that in there, I should get 1, like so. So when I do that, you can see the answer is 1. Now, remember the pi over 4? We can do the same thing with the pi over 4. And so you can see right here I have sine pi over 4 raised to the second power. All this, if I put this in the computer, I get 1 again. You can see how this is working. Now, let's do the last one. You can see right here that if I take, now this is just without the sine or the cosine or with the pi over 4. Here's the last one. I'm taking the square root of 2 divided by 2 raised to the second power plus the square root of 2 divided by 2 raised to the second power. And when I do that, I still get 1. So I was able to get the answer 4 different ways. Or excuse 4 different ways, excuse me. Three different ways. So the first time I did the sine and the cosine, and I put the square root of 2 divided by 2 raised to the second power, and I added them together, I got 1. The second time I did pi over 4 using sine and cosine, and I still got 1. And the last time I just took the x and the y coordinates and squared them, and I still got the same answer. So we confirmed 3 different ways. We confirmed 3 different ways that the coordinates here is square root of 2 over 2, just like you can see right here. So this is kind of the power of the 45, 45, 90 degree angle triangle in relation to the unit circle. Again, this 45, 45, 90 degree triangle is something you learned about in geometry, so it's not completely new or radical here. However, we learned it in the context of relating to the unit circle. So let me kind of wrap up what I'm talking about here, and then we will conclude the video. So in this video, we took a look at the 45, 45, 90 triangle. And so because you have the same angle here, you have the length of the sides is going to be the same. And remember, our primary objective was to try to figure out what is the XY coordinates here on the unit circle when we have this information inside the circle, if you will. And so we know that because these are the same angle, they're going to be the same length. So that allowed us to conclude that x equals y. And so we took that information along with, I kind of forgot to mention this, but the Pythagorean identity, if you will. And we know that x squared plus y squared equals 1. And so we replaced y with x, and we simplified it out all the way to where we got square root of 2 over 2. And then to confirm this, we put this stuff inside the calculator to get the actual answer using the Pythagorean identity, where if x squared plus y squared equals 1, well then sine squared plus cosine squared will equal 1 as well. And we got the same answer. Then we put it in using radians, and we got the same answer. And then lastly, we just put in the actual coordinates into the area of a circle, and we got that as well. So we were able to confirm it 3 different ways. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching. Take care.